So today we're going to do passage 3 of the ACT Science 2012 Form 1 MC. Uh, Solids, liquids, and gases usually expand when heated. 3 experiments were conducted by scientists to study the expansion of different substances. Experiment 1. The apparatus shown in diagram 1 was used to measure the linear expansion of wires of the same length made from different metals. In each trial, a wire was connected to a voltage source, run through a series of pulleys, then attached to a weight. The temperature of the wire was varied by changing the amount of voltage applied. The amount of expansion is directly proportional to the rotation of the final pulley. The results are shown in Figure 1. So diagram 1 is over here, the results are here, Figure 1. We've got linear expansion. I'll just get a magnifier on this. Linear expansion and temperature on the x-axis. And we've got aluminum, brass, iron, nickel. Experiment 2. A sample of liquid was placed in a stoppered test tube fitted with a graduated capillary tube, and the test tube was then placed in a temperature-controlled water bath. The rise of the liquid in the capillary tube was then measured at different temperatures. The results for 3 liquids are shown in Figure 2. So here we have diagram 2 for the experiment, and then we have Figure 2, which shows the rise of the liquid in millimeters, ethanol, glycerin, and water, and the temperature on the x-axis. Experiment 3. A 20 milliliter sample of gas in a gas syringe at room temperature, 20 degrees Celsius, was placed in a temperature-controlled water bath, diagram 3. Changes in gas volume as the temperature increased were measured for 3 gases. The results are shown in Figure 3. Diagram 3 is over here for what goes on. And here, air, nitrogen, and methane, you see the volume, and you see the temperature in degrees Celsius. In Experiment 2, so number 12. In Experiment 2, at which of the following temperatures did all of the liquids tested have the same volume? In Experiment 2, at which of the following temperatures did all of the liquids tested have the same volume? So let's look at Experiment 2 and look at the graph. So we're looking for where all the liquids have the same volume. Same volume. Well, in order to have the same volume, we have to have the same rise of the liquid, right? And so far, I'm going to check if this is correct, but it seems like only 20 degrees Celsius has the same volume. There is 0 rise of the liquid there, and all of the materials have an equal rise of liquid. So let's go down and check the answer. I believe the answer is F. Science, we're on number 12. Yes, I'm correct. The answer is F. In Experiment 2, which of the... Oh wait, we already just did that. So let's do the next one. A scientist has hypothesized that as the temperature of a gas is increased at constant pressure, the volume of the gas will also increase. Do the results of experiment 3 support this hypothesis? So as temperature of a gas is increased at constant pressure, volume will also increase. Let's look at experiment 3 and see if it supports this hypothesis. When we go to experiment 3 over here, a 20 milliliter sample of gas in a gas syringe at room temperature was placed in a gas. Changes in gas volume at temperature increase were measured for 3 gases. The results are shown below. So as temperature increases, volume also increases if you look at this graph over here. So let's look at the answers here. Yes, the volume of all the gases tested in experiment 3 increased as temperature increased. Yes, although air decreased in volume when the when the temperature increased, nitrogen and methane volumes also both increased. No, volume of all the gases tested in experiment 3 decreased as temperature increased. No, although air increased in volume when the temperature increased, nitrogen and methane volumes decreased. All of these are wrong. B, C, and D, they're all wrong. Why? Well, take a look at the graph. Air, nitrogen, and methane. As the temperature increases, the graph also increases. The volume increases. So the answer is A. Okay, let's go to 14. Based on the results of experiment 1, if an engineer needs a wire most resistant to stretching when it is placed under tension and heat, which of the following wires should she choose? Okay, so needs a wire most resistant to stretching when it is placed under tension and heat. Which of the following wires should she choose? Let's look at experiment 1. We're looking at the linear expansion in millimeters. Well, if it's very resistant to stretching, you want the least amount of linear expansion. Well, in each of these graphs, which one of these has the least amount of linear expansion? That's the nickel, right? So let's see if nickel is one of our answer choices. Yes, it is. So the answer should be J. Okay, number 15. Based on the results of experiment 3, if a balloon was filled with air at room temperature and placed on the surface of a heated water bath, as the temperature of the water increased, the volume of the balloon would. Okay, let's look at this. Experiment 3. Based on the results of experiment 3, which is given on this graph right here, if a balloon was filled with air at room temperature and placed on the surface of a heated water bath, as the temperature of the water increased, the volume of the balloon would. Well, as the temperature increases, the volume also increases. So, the air, nitrogen, and methane, the volume of that all increases. So it should increase. 15 should be A, but let me check just to make sure. I was right. 15 is A. If experiment 1 had been repeated using a heavier weight attached to the brass wire, which of the following figures best shows the comparison between the results of the heavier weight and the original weight of the brass wire? Let's look at these answers over here. Let's go back to experiment 1. The apparatus shown it was used to measure the linear expansion of wires of the same length made from different materials. In each trial, a wire was connected to a voltage source run through a series of pulleys, then attached to a weight. A temperature of the wire was varied by changing the amount of voltage applied. The amount of expansion is directly proportional to the rotation of the final pulley, so shown in figure 1. We see the results over here. And we see aluminum has the greatest linear expansion, then brass, and then iron, and then finally the least linear expansion is nickel. However, none of that is relevant to this problem. If experiment 1 had been repeated using a heavier weight attached to the brass, which of the following figures best shows the comparison between the results of using the heavier weight and the original weight of the brass wire? Well, linear expansion increases as temperature increases in the original weight. So A can't be correct because here we have linear expansion decreasing in the original weight while temperature is decreasing. B over here also can't be correct because just because it's heavier doesn't mean that as the temperature increases it's going to decrease. So we're down to either C or D. Now this is where you have to think physics. From what I understand, a heavier material would make the linear expansion greater because that's a heavier mass that's pulling on a certain material. So obviously that would make that stretch. So the answer, I believe, is D. Let's check that. 17. Oh wait, we have to go back to 16 because I forgot 16, but let's check 17 first. Yeah, 17 is a D. The scientists tested a copper wire of the same initial length as the wires tested in experiment 1. Let's copy this. The scientists tested a copper wire of the same initial length as the wires tested in experiment 1. At 80 degrees Celsius, the linear expansion of the wire was 0.12 millimeters. Based on the results of experiment 1, which of the following correctly lists the 5 wires by their length in apparatus at the 80 degrees Celsius from shortest to longest? So let's look at the results of experiment 1. So scientists tested a copper wire at of the same initial length as the wires tested in experiment 1 at 80 degrees Celsius. The linear expansion was 0.12 millimeters. Okay, linear expansion is 0.12 millimeters, and we have 80 degrees Celsius right here. We have nickel, which is less than 0.05, iron, which is a little over 0.05, more like 0.07. We have brass, which is closer to 0.15. It's more like 0.13.5 or something, and then, or 0.135 or something like that. And then aluminum, which is close to 0.20. So I would say it first goes nickel, and then we have iron, and then we have our copper, then we have brass, and then we have aluminum, because brass comes right after copper since it kind of looks a little closer to 0.15 than it does to 0.12. Okay, so the answer is H. Okay, so that was today's video. Please subscribe and join me next time for my next ACT Science video.